Okay, in this video, we are going to analyze some functions, and graphically, we are going to see what happens when we find their product. So we're going to be multiplying here, but we're going to be multiplying graphically. So it's a little bit different, okay? So we're going to do this with a couple of things. We're going to look at problems 1 and 2 that have just lines in them and see what happens when we multiply those together. And then problems 3 and 4 have a line and a quadratic function or a parabola. We're going to see what happens when we multiply those together. So let's jump into problem number 1 here. We want to analyze the graphs of f of x. Well, f of x is the red line, okay, and g of x. And g of x is our blue line. Then sketch and label the graph of m of x. Well, m of x doesn't exist right now. That's what we need to create. And the way we're going to create m of x is we are going to set m of x equal to the product just means to multiply, of f of x and g of x. Now, it's going to be rather difficult to multiply these if we're trying to get exact because there's no numbers on this graph. We have no idea what these functions are, what they're not, so we need to be able to analyze it and kind of get an idea of what our graph looks like. So the first thing we're going to look at is where are our x-intercepts. So our red line crosses the x-axis right here. I'm going to put a big old dot there, okay? And here's the thing. If we think about the product, okay, this point right here has a function value of 0. That's the x-intercept. So no matter what this blue curve is, this blue line, 0 times anything is still going to be 0. So when f of x crosses the x-axis, has a 0 or an x-intercept, m of x, our new function, will also cross the x-axis there. Okay, now g of x has an x-intercept over here, and that's the same thing. So this function value is 0. When we have this 0 here, it doesn't matter what f of x is, 0 times anything is still 0. So these 2 points, those two x-intercepts are going to be the same, okay? So now we've got to figure out what's happening around those x-intercepts. Because now we've got 2 points, which is great. We need to find some more for the curve. Now, one way to do this is to actually split this graph up into intervals. And so what I'm going to do to split it up is wherever these x-intercepts are, I'm just going to draw in a couple of dotted lines here to just split up my graph visually. And I want to see what's happening to the left here, what's happening between these x-intercepts, and then what's happening to the right, okay? So if we look far left here, okay, f of x is below the x-axis, which means all of its function values are negative, okay? And then g of x, the blue graph up here, is above the x-axis, which means all of its function values are positive. So while I'm not sure exactly what those values are, I can know that a negative times a positive means our m of x function is going to be negative. Okay, now I don't know exactly where it is, but if it's negative, I know that it has to be below the x-axis. That much I do know. Okay, so now I'm going to move in between these two x-intercepts and take a look at the graphs here. So in between these two x-intercepts, my red line is above the x-axis, so it's positive, and my blue line is above the x-axis. It is also positive. So if I look at that, I've got a positive times a positive, which means when I multiply those together, my new function, this m of x function, let me get the right words there, is also going to be positive. All right, last little section for this graph, far, far right. So we finally got the blue curve to drop below the x-axis here. So this is all going to be negative. And the red curve, while it kind of doesn't look like it exists, remember this would extend and continue. All right, so the red curve is somewhere up here, the red line, all right, which is clearly a positive. It's above the x-axis. So that's what we've got here. Blue is negative. Red was positive. I don't know why I'm writing out the whole word positive there when I haven't done that for the rest of them. So a negative times a positive is a negative. So that tells me for the curve that we want to draw, the m of x function, I need to start down here negative. I'm going to go through this first x-intercept. Up here between these two, I'm going to be positive, so above the x-axis. Come back through this x-intercept, and then I need to be negative down here, okay? So that curve could look something like that, okay? It's just a sketch. And if you take a look at that sketch, what I'm hoping you recognize is that's a quadratic, that's a parabola, all right? So when you take one line times another line, you multiply them together, you will oftentimes get a quadratic. The last thing we want to do here is to label this line. It's called m of x. So I'm going to put m of x here. And that particular problem's now done. We've sketched the graph, we've labeled it, we can move on. So we're going to keep going number 2 here. And we're going to do the same process, but now we're dealing with 3 lines. Okay, so we have f of x, the red line, g of x is our blue line, and h of x is the purple one. Okay, so first things first, find all of your x-intercepts and label them. So x-intercept, x-intercept, x-intercept. Okay, every one of them. Now what I want to do is separate up the graph. Okay, so at each of these x-intercepts, I'm just going to separate little vertical lines here just to organize my information. Okay, so little dotted lines here. Okay, they don't have to be perfect, but just get the right idea so you can kind of see what's happening here. Okay, so far left section here. Purple line, negative, it's below the x-axis. Blue line, negative, it's below the x-axis. Red line would eventually extend, it'd be down here somewhere, okay, negative below the x-axis. So what's a negative times a negative times a negative? Well, a negative times a negative is a positive, and then a positive answer times a negative means that this is actually negative, okay? So be careful, when you multiply lots and lots of negatives together, it depends on how many you have, whether it turns into positive or negative, okay? Next little section right here, purple line's positive, red and blue are both negative, okay? So we've got positive times negative times negative. Well, a positive times a negative is a negative, and then a negative times a negative makes a positive, okay? All right. As we keep moving from left to right here, so this next little interval, red is positive, purple is positive, blue is unfortunately negative, okay? So we've got positive times negative, whoop, hold on, there was 2 positives and then 1 negative. So positive times positive is positive, but then positive times negative makes negative. All right, far right section here, the red line would extend eventually up here somewhere, so it's positive. Purple is positive, blue is also positive, so everything is positive. So positive times positive times positive will still create a positive. So we want to alternate here, negative, positive, negative, positive. So we're going to start negative, go through the x-intercept here. Positive up here, back through the x-intercept, negative down here, and then back through the x-intercept one more time to end positive up here, okay? So let's see what this graph looks like. So negative, positive, negative, and last but not least, positive over here, okay? So that is clearly not a line. It's clearly not a quadratic. This is actually called a cubic function, okay? And a cubic function is something of the form, and I'm not going to write the whole thing out, but f of x is equal to some form of x cubed, all right? So this is an example, all right, of what a cubic function would look like. The last thing we also want to do here is to label this function m of x, okay? So in this case, we took 3 lines, 3 linear functions, we multiplied them together, and we got a cubic function, okay? So let's see problem number 3 here. What happens when we take a line, f of x here, and we multiply it times a quadratic g of x? All right, what happens when we do that? Well, the nice part is it doesn't matter in terms of how we want to end. The start is still the same. We're still looking at getting those x-intercepts and graphing those. So we've got an x-intercept here, x-intercept here, and here, right? Everywhere we have one, mark it. And then if you want to, if it helps, go ahead and draw in those little vertical lines to separate up your graph, okay? So there's our first little section, our second little section. And you'll notice like these, I'm not taking a ruler to do this. I'm just sketching it in, all right, to get an idea of what's going on. All right, far right, no, this is my left side. So far left section, I can tell my left from my right most days. Far left here, we've got the red line is negative. It's below the x-axis. And what you want to be careful about is you might say, oh, well, the blue line doesn't exist or the blue curve doesn't exist. It does. It just exists way off the page. All right. This curve is going to continue dropping, but also increasing slowly, slowly, slowly to the left. So it is a negative curve. All right. So we've got a negative red line and a negative blue curve, which means what we're going to create is actually going to be positive when we multiply those together. Okay. I'm going to move into my next little section here, my next little interval. The red line is positive, but the blue curve is negative. So what is a positive times a negative? Well, that would be a negative. Okay. Next little section here, this little interval, and it is a little interval, all right, but it's a separator. We have the red line, which is positive. It's above the x-axis. The blue curve is positive. It is also above the x-axis. So let's see, a positive times a positive would be a positive. All right, far right side over here, and this is going to be, let's see, the red line is above the x-axis, that's positive. Blue curve is below the x-axis, that's negative. So we have positive times negative, and that would be negative. So we're going to start positive, go through the x-intercept, make it negative, go through the x-intercept, go positive, through the x-intercept one more time to go negative for the end. All right, so positive means we want to start above the x-axis. All right, so positive, negative, positive. Let's curve that back down to negative. Okay, and let's go ahead and label this one as m of x. So this curve is actually very similar to problem number 2. It is another cubic function. We'll talk a lot more about cubic functions in the next unit, but now that you kind of are seeing them, maybe you'll start recognizing when you take some kind of a line, all right, the red line in this case, times that blue curve or the blue quadratic, you're going to create a cubic function. All right, so number 4 is going to be the last one I do on this particular video. We've got the functions f of x and g of x. We're going to go through and do the exact same thing. All right, I already know we've got a quadratic here times a linear function here. This is going to become a cubic function. Okay, so mark your x-intercepts. Okay, mark those out. If it helps you, go ahead and draw in those separators. It absolutely helps me, so you're going to keep seeing me do it. All right, so I'm going to draw these in, draw these in. Okay, so now let's do a little analysis here. All right, far left. We've got the red line is negative, blue curve is positive, a negative times a positive is a negative. All right, next little section. Red line here is negative, blue curve here is negative, negative times a negative is a positive. Next little section right here, you've got a negative red line with a positive blue curve. So negative times a positive is a negative. And then last section over here is this far right. We've got the red line is above the x-axis finally, so it's positive. The blue curve is somewhere up here, so it's positive as well. So positive times positive is positive. All right, so we're going to start with negative. Come up here for positive, negative, positive. Okay? And label the graph as m of x. All right, so hopefully this is giving you an idea of how to analyze these functions that don't have any values. All right, there's really nothing that we can analyze other than knowing where the x-intercepts are. So we're going to use that information, and then knowing whether the function is positive. Positive means it's above the x-axis, or negative means it's below the x-axis. Hope this has helped.